So far, we've been able to configure Nginx as a reverse proxy for our ChatCat Node.js app. Node.js apps can handle a large number of concurrent requests easily. However, a single instance of the app running on a server is bound to hit a brick wall when the quantum of traffic picks up pace. And when that happens, requests would be denied and basically you lose out on visitors and potential customers. In a high traffic situation, you need to distribute the incoming traffic over a cluster of servers all running instances of the same Node.js app. Consider this familiar situation. For instance, we created a single cloud server instance here on DigitalOcean and earlier in the course on Amazon Web Services, and we installed our Node.js app on it. In this section, we also installed Nginx as a proxy for our Node.js app. In this case, everything is on a single server, which will lead to the situation which I have just mentioned. The power of cloud servers is in its ability to easily spin up new server instances when needed. So let's say we do spin up multiple servers with each running instances of the Node.js app. We still need a mechanism that distributes our load across these servers when the traffic peaks. That is precisely what a load balancer does. Nginx is a fantastic load balancer. This is how a practical deployment should look like. Here, let's say Nginx is set up to run on a server with the IP address 104.236.40.71. Then we can set up multiple cloud instances, let's say, and hook them up to Nginx, which will evenly distribute the load as it peaks. Here, the IP address mentioned is for illustration purposes only. The beauty of this setup is that you can easily add more servers as the load goes up. So for instance, during a Black Friday sale, let's say, anticipating a more than usual amount of traffic, more instances can be spun up, and once that period elapses, can be removed. This way you only incur cost for running the servers for the duration that they were up and running and still be able to manage the load and deliver efficiently. So let's say we consider this illustration as a real world scenario. Let's see how we can easily configure Nginx to work as a load balancer. We're in our configuration file in the sites enabled folder, and let's say we have the 4 server instances up and running with the Node.js app running on port 3000. All we need to do is add references to all the servers in the upstream block. That is it. It really is that easy. One problem that can arise, though, is with sessions. Server-based client sessions persist as long as you're connected to the same server. In a load balancing act, a single user may be sent across multiple nodes, and this obviously means that sessions will not persist. Nginx, however, has a simple solution to that as well. Just put IP_hash at the beginning of the upstream block, and Nginx will ensure that a user stays on the same instance. This ensures that a user's session stays intact, something that we need to ensure even for a simple app like ChatCat. I'm sure this section will prove quite useful when you deploy your Node.js apps on the cloud in a production environment. Whether you deploy on Amazon's EC2 instances or DigitalOcean or any other cloud host, the rules of deployment remain the same. And with Nginx at your side, with its reverse proxy, file caching, and load balancing, you can be sure your web application is ready to face the world with open arms.